Curve sketching. We would like to sketch a curve y is equal to f of x. Now, here there are two graphs which are very helpful in sketching curve. They use the signs of derivatives to determine the shape of the curve. The second derivative is positive. The shape of curve look like this. It depends on the first derivative. First derivative is negative. First derivative positive. First derivative is 0, which is a minimum. The second derivative is negative. The shape of curve look like this. First derivative positive. First derivative is negative. First derivative is 0, which is maximum. Okay, so these two graphs are very helpful in sketching curve. Now let's see the first example. This one. This function. The domain. The domain is for all real numbers. So we sketch the curve from minus infinity to positive infinity. First derivative is this. Now we know that this function is always positive. This function is always positive. Means what? Means this function is increasing in entire domain, which means the function is monotonically increasing. Now the second derivative is e to the power of x, which is always positive. Okay. Now at 0, y is equal to 1. So this is the point. This is the point, the curve passing through. Now based on these pieces of information, we can sketch the curve. The function is always increasing. The function is look like this. I mean increasing, right? Like this, passing through that point. So the function like the curve like this right away. Okay, increasing, look like this. Second derivative positive, passing through this point. Now this point is x-intercept. It's not necessary, to find out. Well, if you want, you can let this be 0. You find x, right? But which is not necessary in sketching our curve. So that is number 1. Number 2, this function. This function, the domain is all real numbers. Now the first derivative is ex minus 1. Now this function, this derivative is negative when x is less than 0. It is 0 at x equal to 0, and positive when x is positive. So that will describe the curve, second derivative is always positive, means the second derivative look like this. Decreasing, increasing at 0, which means at 0, at x equal to 0, y is equal to 1. Y equal to 1, right? So this is a function, the curve passing through. The function look like this, second derivative positive, and before 0 is decreasing, after 0 is increasing. So the function look like this, right? Yeah, very nice curve. Very nice way of obtaining the curve. Okay, this is very very nice way to sketch the curve. Now, next example, this function. First, this function, the domain is x is positive. So we are sketching the curve. We are sketching the curve from, at quadrant 1 and quadrant 4. Okay, that function is a sketch. The domain is over there. Now the first derivative is this. This one is always positive because x is positive. X never be negative. So first derivative is always positive. Meaning what? Meaning function is monotonically increasing in its domain. The second derivative is always a negative. So the curve looks like this. This shape depends. If it's increasing, then the curve will look like this. See, look like this. And when x approaches to positive infinity, when x is approaches to 0 from a right hand side, this function is a negative infinity. So therefore we have an asymptote. At x equal to 1, y equal to 1. When x equal to 1, y equal to 1. So this is the point. This is the point the function passing through. Okay. Monotonically increasing. Asymptote. The curve shape look like this. So that then we can sketch the curve. Okay. This is a very nice way to sketch the curve based on the shape of the curve using derivatives and consider other factors like asymptote and particular point and so on. Now, next example, this example. We know that the domain is positive value for x because log x, right? X cannot be negative, cannot be 0. And then we take a derivative. From this derivative, we know that when x is less than 1, it's positive. When x equals 1, it's 0. When x is greater than 1, it's a negative. So these signs determines the function is increasing or decreasing at what interval. No. And the second derivative is always negative. That means the shape look like this. Shape look like this. Now when x equal to 1, y equal to negative 1. Look, when x equal to 1, y equal to negative 1. So this is the point. This is the point. The curve passing through. And at a 0, second derivative is negative is maximum. When x approaches 0, y is a negative infinity because of the log function. So combine these information, we can have see the curve look like this, right? You can quickly review that. Function is increasing before 1. This is increasing. After 1 is decreasing. At 1 is 0, which is the maximum. The second derivative is negative. You see, second derivative, the shape look like this. Okay, these considerations are very useful to sketch the curve. Okay, I will have a series of maybe 6 videos talk about the curve sketching. This is the first episode. So because I don't want to put too many examples in one video, okay? So let's see next one. Until next, thank you for watching, and there are more to come.